Energy and power in electrical circuits. Heat produced in a resistor. When a battery is connected between the ends of a conductor, a current is established. Consider a circuit in which a battery of voltage V is connected to the resistor as shown in the figure. Assume that a positive charge of dq moves from a point A to B through the battery and moves from a point C to D through the resistor and back to point A. When the charge moves from point A to B, it gains potential energy. And when it goes from B to A, its energy, potential energy, converted into kinetic energy, and it collides with atom, then it produces heat, and that heat will be lost to the surrounding. So the gain potential energy d epsilon equals V dq, and the chemical potential energy of the battery decreases by the same amount. When this charge dq passes through the resistor, it loses this potential energy due to collision with the atom in the resistor, produces heat energy that is lost to the surrounding and again reaches the point A. So the heat energy dH equals VI dt. We replace dq by I dt. So H equals VIT joule. This is called Joule's law of heating. Joule's law of heating. H is equal to VIT. We replace V. We replace either V or I by using Ohm's law, right? So V H is equals VIT equals V square by R times T equals I square RT joule. Joule's law holds good only for ohmic conductors. Joule's law holds good for AC, but V and I are replaced by VRMS and IRMS. According to this law, the heat produced in the resistor is 1. Directly proportional to the square of the current for a given R. Heat produced in a resistor is directly proportional to the resistance R for a given I. Third, heat produced in a resistor inversely proportional to the resistance for a given voltage. 4. Heat produced in a resistor is directly proportional to the time for which the current flows through the resistor. So, this gives a complete meaning of Joule's law of heating. Electrical power. The electrical power P is rate at which the electrical potential energy is delivered by the battery. The electrical power is the rate at which the electrical potential energy is delivered by the battery. It's all about the source. P equals d epsilon by dt. D epsilon is replaced by V dq. So dq by dt becomes the current. So P equals V times I. The expression gives the power delivered by the battery to any electrical appliances. Here I is the current flowing and V is the potential difference across the electrical appliances. The SI unit of electrical power is watt. 1 watt equal to 1 joule per second or 1 volt ampere. The bigger units are 1 kilowatt hour and 1 megawatt. The commercial unit of power is 1 horsepower equals 746 watt. Using Ohm's law, power delivered to the resistance R is given by the form, different form, P equals V times I. Here we replace V by IR times I, so we get P equals I square R. And this is a little come wrongly here. So second way, P equals V times I. Now I replace current by V by R. So power equals V square by R. So let us combine all this small formula. P equals V times I equals V square upon R equals I square R. The unit is watt. This expression gives the power delivered by the battery to any electrical system, where I is the current and V is the potential difference and R is the resistance of the electrical appliances. Electrical energy. The total work done by the battery in maintaining the electrical energy in a circuit for a given time is called electrical energy consumed in the circuit. The total work done by the battery in maintaining the electric current in the circuit for a given time is the electrical energy consumed in the circuit. Electrical energy W equals P times T. Let us replace P by VI times T. So we get W equals I square RT. This expression gives the electrical energy delivered by the battery to any electrical appliances or system. Here I is the current, R is the resistance, and T is the time of flow. V is the potential difference across the electrical appliances. The SI unit of electrical energy is joule. So electrical energy is measured in kilowatt hour. This is a commercial way of measuring. So 1 kilowatt hour equals 1000 watt hour. The hour is replaced by 3600 seconds. So we get 1 kilowatt hour equals 3.6 into 10 power 6 joule. Power rating. The rating of an electrical appliances indicates that the voltage at which the appliances is designed to work and the power consumption at that voltage. The rating of an electrical appliances indicates the voltage at which the appliances is designed to work and the power consumption at that voltage. Resistance of the appliances equals voltage rating of the appliances square upon power rating of the appliances. Safe current equals power rating of the appliance upon voltage rating of the appliance. Commercially, the electrical bulbs are used in houses come with power and voltage rating like 5 watt 220 volt, 30 watt 220 volt, 60 watt 220 volt, etc. Usually, this voltage rating refers AC RMS voltages. For a given bulb, if the voltage drop across the bulb exceeds the voltage rating, the bulb will fuse. Power consumption in a combination of appliances. Power consumption by a series combination of appliances. Here, three bulbs with rating P1V, P2V, P3V are connected in series with the battery V. Consider a series combination of three bulbs of power rating P1, P2, and P3, which are manufactured for working on the same voltage rating V. The resistance of the three bulbs will be R1 equals V square by P1, R2 equals V square by P2, R3 equals V3, so V square by P3. As the bulbs are connected in series, the effective resistance, the equivalent resistance R equals R1 plus R2 plus R3. So let us replace all these resistance. V by P equals V by P1, sorry, V square by P equals V square by P1 plus V square by P2 plus V square by P3. If P is the effective power of the combination, then 1 by P equals 1 by P1 plus 1 by P2 plus 1 by P3. This is a very important conclusion. Let us write this near the diagram. Let us go for the tips and tricks. Clearly, when n bulbs of same power P are connected in series, P effective equals P by N. Important formula. The current is same throughout the circuit. So I equals V by R1 plus R2 plus R3. So this is the most important conclusion. The brightness of each bulb proportional to the power what it gets at that time, which is proportional to the voltage available across the bulb, which is proportional to the resistance, which is proportional to 1 by the power rated. The brightness of the first bulb P1 prime equals I square R1, P2 prime equals I square R2, P3 prime equals I square R3. The bulb with lowest power rated has the highest resistance and it will glow with maximum brightness. So power rate and resistance are inversely proportional. Correct? Okay, good. When the current in the circuit exceeds the safety limit, the bulb of the lowest voltage will fuse first. Power consumption by parallel combination of appliances. Here little error, it is not series combination, it is parallel combination. Consider a parallel combination of three bulbs of power rating P1, P2, P3 which are manufactured for working at the same voltage rating V. So the resistance of the three bulbs will be R1 equals V square by P1, R2 equals V square by P2, R3 equals V square by P3. The bulbs are in parallel, so the equivalent resistance 1 by R equals 1 by R1 plus 1 by R2 plus 1 by R3. Let us multiply both sides by V square. So we get V square by R equals V square by R1 plus V square by R2 plus V square by R3. If P is the effective power of this combination, parallel combination, then P equals P1 plus P2 plus P3. Let us write this near the diagram. Let us go for a little more conclusion. Clearly, when n bulbs of same power P are connected in parallel, then the total power equals n times the power of each bulb. Brightness proportional to the power, that is proportional to the current, which is proportional to 1 by resistance, which is proportional to the rated power rate. So the brightness of the three bulbs will be P1 prime equals V square by R1. P2 prime equals V square by R2. P3 prime equals V square upon R3. So the bulb with the highest power rated has the lowest resistance and it will glow with maximum brightness. When the current in the circuit exceeds the safety limit, the bulb of the highest voltage will be fused first. Thank you, children.